Greetings, I'm Squared here. Today we are going to review our exponent rules. So this is an Algebra 1 class. These are what you're expected to know, but a lot of times we forget things that we learned in 8th grade and so on. So we're going to review these a little bit, and then we'll move on to this new stuff that you're going to learn this year. So first of all, we want to talk about the different rules. So the zero exponent rule says that anything raised to the 0 power is 1. So a lot of people think it's 0, but anything raised to the 0 power is 1. Your calculator will tell you such things. The reason why has to do with this rule, the quotient power. So the quotient power says that if I have some a or like base, remember the bases are the same, a to some power divided by a to some power, that I subtract the exponents. The reason I do that, let's say I had a to the third and a squared. Well, what a third to the third means is that I have a multiplied by itself 3 times, and a squared means I have a multiplied by itself, 2 times. And what happens when I have something like that is I say, well, a divided by a is 1, and this a divided by this a is 1. So I'm left with 1 times a, or just a. Well, that's the same thing as a to the 3 minus 2, because 3 minus 2 is 1. And a to the first power is just a, because that means there's 1a. So that quotient rule can be used to show why this is 1. Let's say I have a squared divided by a squared. Well, you should recognize any time that the same thing is in the numerator and the denominator, that that's 1, because anything divided by itself is 1. 5 divided by 5 is 1, 10 divided by 10 is 1. So we already know that's 1, but if we use the quotient rule, we can see that it's a, and then we take this exponent and subtract it from that exponent, and 2 minus 2 is 0, so a to the 0 is 1. We already knew it was 1, but this kind of just proves it. So basically, when you have a to some power that's a 0, you're saying, hey, you just divided the same thing by the same thing, so it's 1. Next are negative exponent rule. So negative exponents never ever make anything negative. That's really important to remember. Whenever you see a negative exponent, it just means it's not where it should be. That's kind of how I liked it. They like to move it. So a negative exponent becomes positive if you move it from the numerator to the denominator, or if it was negative in the denominator and you moved it to the numerator, kind of like this. If I had 1 over x to the negative 3, that's the same thing as x cubed. Notice the x stayed the same, the base. The 3 stayed the same. It's just that when I moved it up, the negative went away. So a negative exponent just means that if it was moved to where it's not, numerator or denominator, that it would be positive. The power of a power rule says that if you have some base raised to a power and you raise that whole thing to another power, that you multiply those. So it's kind of like if I had a squared cubed. Well, cubed means a squared times itself 3 times. That's what cubed means. There's 3 of them. And then this means a times a times a times a. So I end up with having 2, 4, 6 a's, or a to the 6th, or 2 times 3. So that's how that power rule works. Power of a power. This is a product of powers. So we have a product, that means multiplication going on, and we add the powers. So if I had a to the 5th times a cubed, that gets me a to the 8th, because I have 5 of them all lined up here, 3 of them, so all together I have 8 of them. And this is a power of a product, so we're multiplying and then raising it to some power. And when that happens, we can split it up. Either one of these works. Sometimes this one's more convenient because of what you're doing. Sometimes you like it like this. It just depends on what you're doing, but just know that those are interchangeable. So if I had 2a to the 5th, that's the same as 2 to the 5th, a to the 5th. Okay, so now that we know our rules, we're going to get started. So we're going to do this in a couple days in class, but we're going to do them all for our little video. Okay, so here's the tricky one. 5 times x to the 0. Some people see the 0 and they think, oh, it must be 1. But it's 5 times 1, because this is 1, but 5 is not 1. 5 is not raised to the 0 power, so 5 times 1 is 5. Now that's different than if I said 5x whole thing to the 0. That would be 1. So keep track of that, because sometimes that can trick kids. So I don't know if you can see that really well. I'll try to zoom in, because that's a negative. So y to the negative third power, it's okay to leave it that way, but if the directions say use only positive exponents like our directions, then we want to change it. And remember, all we have to do is move it to where it's not. So move it to the denominator, and then it becomes positive. Same thing as if I had y to the negative 5 over x to the negative 2. They're both negative, so if I moved this guy up, he would become positive. If I move that guy down, he would become positive. So a negative exponent, just move that whole expression to the numerator if it's in the denominator, and it becomes positive. The exponent becomes positive. All right, we're multiplying, so we just add exponents. So that's just x to the 8th. We're dividing, so we subtract, and it's 7 minus 10. It's always the numerator minus the denominator if you're going to keep it in the numerator. If you wanted to put that in the denominator, I'll show you how to do that. You could say 1 over y to the 10 minus 7, or 1 over y cubed. So you can do it either way, subtract down or up, but if you're subtracting from the top to the bottom, you want to keep it in the top. From the bottom to the top, you want to keep it in the bottom. It's kind of like, you can see that there's more y's here. There's 3 more y's here than there are here, so they're definitely going to need to go in the bottom. Okay, so this is kind of a combination. So we have this n, and this n that we need to combine. But we also have numbers. So I'm going to do the numbers first. What's 2 times 3? That's 6. Now I'll take the n's, and since they're all being multiplied, it's 3 plus 0 plus negative 2. You could have also recognized that that's a 1 and ignored it, because 2 times 1 is 2. But if you want to use this product of powers rules, then you want to know how to add all the exponents. So that's 6n to the first power. We don't have to write a 1 when it's a first power, because 3 plus 0 is 3 minus 2 is 1. You can put the 1 there if I'm your teacher, or you can leave it off. But some teachers say it's not simplified, so you want to watch out for that. Okay, here we go. We're multiplying again. So we're going to do the numbers first. 3 times negative 2 is negative 6. X to the negative 4 and x to the 5th, that's negative 4 plus 5. Because I'm multiplying, I'm going to add the exponents, because I have, this is kind of like having 4 in the denominator and 5 in the numerator. And then y to the 3 plus 4. So then to simplify that, I get negative 6x y to the 7th. Because 5 plus negative 4 is 1, and 4 plus 3 is 7. Okay, so here is our power of a power rule, and that's to multiply. Because remember, squared means x to the 6 times x. Sorry, x. Let me try again. X to the 6 times x to the 6th, which is just x to the 12th. You don't have to do that. You multiply 6 times 2. So that's what we should be using when we do that rule. But I'm just showing you what it means. And then this one, it's x to the 2 times 4, and then y to the 3 times 4. So that gets me x to the 8th and y to the 12th. Again, this intermediate step is not necessary. You can just go here, but I'm just showing you what I did. Now these are tricky sometimes for students, because what they do is they see the 2 and they don't see the exponent on the 2. This rule needs exponents. So I always like to teach kids to write a little 1 up there while you're learning this rule, so that you can say 2 to the 1 times 3 times x to the 4 times 3 times y to the 1 times 3. And then we get 2 cubed x to the 12th y. And if you want to simplify that, some teachers want you to, it'd be x to the 8x to the, forgot my 3, 8x to the 12th y cubed. Like that. All right, now we're dividing. So just like when we multiplied, where I did the numbers first and then the x's and then the y's, I do that when I'm using fractions too. So I have 1 and a 4, so that's just a 4. I have x and x cubed. So what I like to do is I sometimes grab my highlighter and I highlight each one where the number is positive in the top or the bottom. So I look at the x's. And I see that that's a 3 down here and the y, and there's the 4 here, and those are the biggest ones. So then that would be x squared down here, because it's 3 minus 2, and then 4 minus a negative 3 is 7. So now I'm going to move on to this rule, and I've got to take 4 cubed and then x squared cubed times 2 to the second power and x to the negative 10, and then I can simplify it. 4 cubed is 64, and that's 64 times 4, and then I can combine these. That's x to the negative 4. So the x is going to go on the bottom, and then that's 16, 24, 25, 256 over x to the 4th. And our last problem for today, numbers first. 2 goes into 4 2 times. If I subtract, this one's bigger here, this one's bigger here, so it's going to be 4 minus a negative 3, which is 4x to the 7th, and 7 minus 5, which is y squared. So I always keep track of where I'm going to put things. The 4 was bigger than the 2. Alrighty, good luck with that. M squared signed in.